We just learned that when you combine energy of the main shell and relative energy of the subshells, knowing that subshell S have got minimum energy and next higher energy or subshell P, higher than that subshell D, higher than that subshell F. In combined factor, now you have energy of electrons in an atom, minimum energy is 1s, and then 2s, then 2p's, 3s, 3p's, 4s, 3d's, 4p's, 5s, and 4d's. So electrons in an atom, they feel the minimum energy level, and then they go to higher energy. So can I say 1s quantum number, principal quantum number is number 1, that's the first shell, and L equal to 0 is showing that the shape of the electron cloud is spherical. So 2s belongs to second shell. L equal to 0 is showing a spherical electron cloud, but the radius of 2s is larger than radius of the sphere, which belongs to 1s. And then n equal to 2 is showing second shell. L equal to 1 is showing p subshells. N equal to 3 is telling you that we are talking about the third shell, the third main shell, and L equal to 0 means a spherical electron cloud. So we say this must be representing 3s electrons. And n equal 3 is third shell, L equal to 1 is p subshell. So we show these as 3p, and you remember in p orbitals there are 3, in p subshells there are 3 orbitals. And then in these subshells, we showed it to you that L is equal to 2, and if it is n equal to 3, we call it 3D. And remember, they come in quintuplet sisters, they have same energy, but different orientation in space. And so on and so forth. So these are the relative energy of orbitals. And Aufbau principle says fill up electrons in lowest energy orbital, and when they are totally filled, go to the next higher energy. So if I talk about hydrogen atom, which has got 1 electron, can I say configuration is 1 electron in 1s, so 1s1 is the configuration for electron notation for hydrogen atom. And if I go to helium, we have got 2 electrons. Remember, we said each orbital can accommodate 2 electrons, so we will have another electron in 1s, except when 2 electrons are in the same orbital, they must have opposite spin. So up arrow and down arrow is simply showing that these 2 electrons are paired, they have opposite spin, their magnetic field is going to be attractive. So helium has electron configuration of 1s2. And if I go to lithium with 3 electrons, where would the third electron go? Well, once 1s, which is 1 orbital, which can accommodate 2 electrons, obviously the third electron must go to the higher energy level, and it will go into 2s. So what is configuration of lithium? 2 electrons in 1s and 1 electron for 2s. What about beryllium, which has got 4 electrons? Can you guess? Yes, the 4th electron can pair up with another electron in 2s. So now the configuration is 1s2 and 2s2. What about boron with 5 electrons? Where would the 5th electron go? Because 1s and 2s are filled. There is no choice for the electron to go to 2p. So the electron configuration for boron is 1s2, 2s2, and 2p1. And if I want to write electron configuration for carbon, which has got 6 protons and 6 electrons, atomic number is 6, where would the 6th electron go? Would it pair up with this electron? Is it going to pair up here and leave the other orbitals empty? That's one choice. Or would it try to get its own orbital? This is answering question if somebody else is paying for your hotel and you are not with your partner, wouldn't you want your own room with more privacy, or would you share your room with somebody else? Electrons do the same thing. Electron will try to occupy maximum number of orbitals. They would like to be single unless they don't have a choice. So this one is not acceptable. This is a better case where each electron has its own orbital. And this is called Horn's rule. So electron will try to have the greatest number of parallel spins. Simply means electron will try to occupy maximum number of electrons. So electron configuration for carbon is going to be 1s2, 2s2, and 2p2. What if I go to nitrogen? Where would the next electron go? Where would next electron beyond 6 would go? Right in here. Again, electrons will try to occupy maximum number of orbitals if possible. So that is electron configuration 1s2, 2s2, 2p3. That is electron configuration for nitrogen. And for oxygen, which has got 8 electrons, one more electron. Remember, each orbital can have maximum of 2 electrons. There is still room here for another 3 electrons. So that one electron is going to be accommodated. So one of the p orbitals are going to be paired, a pair of electrons. So oxygen is 1s2, 2s2, and 2p4. And for fluorine, which has 9 electrons, remember we still have room here. The next p orbital, which was singly occupied, is now paired. So 1s2, 2s2, and 2p5, yes? And neon with 10 electrons, we are going to complete 6 electrons that 2p subshell can accommodate. And then 4 electrons in 2s and 1s. So 1s2, 2s2, 2p6. That's the electron configuration of neon. So this is the chart I'm giving you on the exam table. So you start writing a column from 1s, 2s, 3s, 4s, 5s, 6s, 7s. From the second shell, start with 2p, then 3p, 4p, 5p, 6p. Third shell, you start Ds and going up from 3D, 4D, 5D, 6D, and F starts from the fourth shell, 4F, 5F. And then, as I said, you don't have to write these. This is already coming with your exam table. Just go diagonally. After 1s, there is 2s. Go the same direction diagonally, then 2p, and 3s, and then 3p, and then 4s, and then 3d, 4p, 5s, and then so keep going diagonally. Then you can write orbitals in relative energy, in order of increasing energy, and that's what you get. You get this chart, but you won't get this one. You have to write this relative energy by using the information inside this light green card, inside this information. So again, in writing the electron configuration, we went through these principles. Aufbau principle. Aufbau principle says lower energy orbital fill first. We also make sure we don't place more than 2 electrons in each orbital. But this, we said electrons try to occupy maximum number of orbitals. So they don't pair up unless they have to. Let's do 2 examples before we go to next video. What is the electron configuration of magnesium? You look up the atomic number of magnesium in periodic table, and do you see atomic number is 12? So magnesium has got 12 electrons. Relative energy of orbitals is obtained from the chart that I told you about, and then place 2 electrons in each orbital. Once they are filled, go to the next, and this is what you get. 1s2, 2s2. Remember, P's are coming triplet sisters. P subshells, you can accommodate 6 electrons because there are 3p orbitals. Next one is 3s. That's 2. Let's count total number of electrons. 2, 4, plus 6, 10, plus 2, 12. So this is the configuration of magnesium. What is the electron configuration for chlorine now? Oh, guys, before I go to the next problem, how many electrons are there in neon? Look up the table. Is it 10? So what is electron configuration of neon? Is it 1s2, 2s2, 3p6? That's 10 electrons, right? Do you see how these two are identical, right? 1s2, 2s2, 2p6. That's electron configuration of neon. So I can replace these 3 by writing neon configuration, right? Neon inside a bracket. So we are doing shorthand notation. Instead of this, I said neon configuration, and then I write what is left over neon configuration. So if I do this, this is shorthand notation. We call this noble gas configuration. This is called noble gas configuration because we are using neon, which is a noble gas, belongs to the group 8A. So you can write full configuration, full electron configuration. This is called full electron configuration. Full electron configuration versus shorthand noble gas configuration. Just respond to the question. What is question asking? Respond to that. If question is not telling you exactly which one, you have the option of doing either. So what is electron configuration of chlorine? You look up the periodic table, you see atomic number is 17. 17 protons, therefore 17 electrons. Relative order of energy of orbitals is this. 1s, 2 electrons is filled, you go to 2s, 2 electrons filled, you go to 2p subshell. Remember, they can have maximum of 6 electrons, then 3s, 2 electrons. There are only 5 left, which can be placed inside 3p's. Each p orbital can accommodate 2. And you have 5, you still have room for 1 more electron, even if you go to atomic number 18. I hope these make sense. If they don't, please come and see me during my office hours and lab time. I'll be glad to Zoom with you. One-to-one cases. Thank you. Have a wonderful day. Until the next video.